So this talk looks really promising from what I heard. I never actually heard of what trusted firmware is, but from what I've heard, it's pretty thoughtful. It's pretty forward-looking, forward-thinking, and it's really planning ahead on the ARM architecture in terms of security and firmware. So yeah, that sounds promising. Give a round of applause, please.
Thank you. Thank you, everyone. Thanks for making the last slot of the day. It's going to be tough, I know. So I'm Matteo Carlini, and I'm going to present you the Trusted Firmware project and the effort around standardization for open source firmware in the ARM ecosystem. So the problem is not only I'm the last slot of the day, but it also got the longest presentation title of all the conference. Don't ask me why I choose that one. But the important thing is that I would like you to just remember the first two words, so trusted firmware, and have an idea, a rough idea on what it is when you leave this room. So that's the goal. So who am I? So I'm part of ARM. I work in the open source software organization in ARM. I look after all the developments that ARM does in the open source firmware world. So not only trusted firmware, but we are also very active in the Tiano Core EDK2 space. And we have another open source project for power management on ARM that is called SEP. On top of that, I'm also proud to be the chairman of the board for the TrustedFirmware.org project. And that's why I'm representing here that project. I'm based in the lovely Cambridge, UK, and I'm a long-time football fan. Actually, that's me visiting the Manchester United Stadium, the Old Trafford in Manchester. That's one of the most important one in the UK. Please don't ask me about American football or soccer. There is only one football, right? So contacts are there if you want to reach out. I'll be around for the rest of the week anyway. So the agenda is pretty simple, two sections. So the first one is more like product, historic, marketing oriented. The second one is the bit more technical one. So I know you are tired. You can decide if taking a nap on the first slot or on the second. I would just try to keep you awake anyway. OK, so let's go. Let's take a ride back in time. So not as much as Rob did this morning, but almost, so quite a few years ago. And I have a little trivia for you here. So let's see if you can spot which year it was. So it was the year in which an 18-year-old Cristiano Ronaldo signs for Manchester United, if you know who it is. The second guy is probably more popular here. It was a movie star that went into politics that year. The third one, it's a curious one. The Human Genome Project was declared complete in that year. And obviously, The Lord of the Rings, The Return of the King was the highest grossing movie in the year of the Lord, 2003. But that's not the important thing. So in 2003, ARM introduced the Trust Zone concept. So Trust Zone was introduced as an architectural extension. Back in the time, there was the ARM v6 architecture. So ARM v8 was far, far away in the future. So ARM Trust Zone introduced, for the very first time, the concept of secure word execution environments isolated from the normal word execution environments, controlled by a bit, the infamous NS bit on the AMBA bus. So that's the earliest article I could spot it on the internet that, again, 2003, present Trust Zone. So fast forward a bit of years. Again, let's try again this exercise. So a much more mature Cristiano Ronaldo wins the Ballon d'Or for the best European football player that year. The movie star is back to movies, actually, with another young actor. Console wars continues in the console space, like the 1980s, but that's not Sega and no Nintendo. And Minions make a laugh at Gandalf at the very, so with their Despicable Me #2 movie that beat The Hobbit in cinemas. So anyone wants to try? So this one was the year 2013. And in 2013, ARM launched with the first commit on GitHub, the ARM Trusted Firmware project. So ARM Trusted Firmware project came basically together with the ARM v8 architecture to provide the reference implementation for secure world firmware running on the ARM v8 architecture at the time. Now we also introduced support for ARM v7. A bit of history since then. So 5 years of history till 2018. So as I said, the idea was, with the brand new ARM v8, propose an open source firmware from the start to defragment the highest privileged firmware space on the ARM architecture. So that was the goal. Released on GitHub initially, 5 years of major releases. Let's jump to fall 2017. So after many years, standardization, spec support, trusted boot, power management spec, and so on. In the fall 2017, ARM also introduced the Platform Security Architecture Framework. So this is a framework mostly coming from the IoT market space for securing all your IoT devices. But that also was the opportunity for creating a sibling project, so the Trusted Firmware for the microcontrollers. So given the success of Trusted Firmware for the application processor, Trusted Firmware A, how it is called today, ARM launched the sibling project, Trusted Firmware M. And together with that, we decided that it was time to open up the governance of that project so that it's going to be no more an ARM open source project under the ARM GitHub space, but it's going to be a very true open governance community project. And that's what it is right now. So ARM Trusted Firmware is no more called by that name. Now we are in the fall 2018, last exercise. So Cristiano Ronaldo finally signs for a big team back in Europe. That's Juventus. That's my team. Mr. Arnold is shooting the last Terminator movie. Protests in Britain for something called Brexit. I don't know what it is, really. And Incredibles #2 is a good movie. But here we go. TrustedFirmware.org is born. In the fall of 2018, TrustedFirmware.org is born as an open governance community project, keeping the very same permissive license as the originating projects. So it's BSD-free clause, all contributions accepted under DCO, so Developers or Certificate of Origin. No need to sign anything if you want to contribute. Everyone is welcome. Please go and contribute to that project. If you want to join the project itself, the project membership gives a seat to the board of project member representatives and gives a seat to the technical steering committee. And these are the two bodies that drives the strategic and technical direction for the project. There are publicly available resources of all kinds, mailing lists, roadmaps, meeting minutes, and so on. And as of today, well, actually as of 3 days ago, but that's the same, August 19, so the project is the combination of 3 major open source projects. So as we said, Trusted Firmware for the A class, for the M class, and also recently OPT. So I'm not sure if you know what it is, but OPT is the reference trusted OS implementation that was originally provided by Linaro. Now Linaro proposed, and the Trusted Firmware project accepted the inclusion of OPT within the TrustedFirmware.org umbrella project. So we'll see in a minute how this will translate in the ARM architecture from a reference software point of view in the secure world. So these are the current members. You will see there is a different variety of market segments that are represented. ARM and Linaro just sits as one of the 2 founding members, but then there are all the other companies that are contributing actively to the life cycle of the project. As I said, it covers all different kind of market segments in which there are ARM products around. So it goes from end user devices of all kinds, so wearables, IoT, mobile, all the smartphones that you have in hands, automotive, everything that is on an automotive system, as well as laptops, so laptops on ARM machines. And then it goes down to embedded, edge, router, gateways, down to the cloud and the more traditional general purpose server segment. So it really covers a huge variety, and this also translates in a huge set of very different security requirements when it's down to securing your platform, because all of these have different threat models, different security requirements at the end. So which are the key pillars, the goals upon which the project was created? Well, quite simply, so trying to solve the security issues by scale. So take an example, the Spectrum meltdown mess of 2018. So if you are able to solve Spectrum meltdown in one single code base and then deploy it across all these segments that we saw before, so we've done a great success. So we fix it once and for all across all these segments. So joining the project gives shared responsibility to the security of your products. It obviously helps reducing time to market and development costs. That's the traditional argument for using and contributing back to open source projects, less individual maintenance, and minimize cost of ownership for the project adopters. And as I said, so at the end of the day, your security complexity is solved once and for all in one place, in one code base that you can then audit, assess, and deploy across all your products in all your segments. So that's one important thing that we recently set up on the project. So we have an OpenCI system that continuously tests every single commit that goes under the open review systems. It gets tested on a Lava system that is managed by Linaro as a contractor company. And it's tested currently against ARM platforms. So there is a microcontroller-based platform, the MPS2, and an application controller-based, the popular Juno development board. But we obviously foresee that partners will donate, project members will donate their boards to be contributed to the OpenCI. So every single commit will be tested against all partners' boards that are available in the OpenCI system. That is already live, so you can go and look at the URL. It's already working for every commit that gets reviewed in open. So some statistics shown by Cristiano up there. So as of the first 6 months of 2019, half of the commits are coming from the ARM ecosystem and not from ARM. So we reached the point, almost the point of, in which the partners are contributing more than ourselves. We have more than 30 partner platforms from 16 different vendors. And this is not counting the ARM development boards. So the ARM development boards, there are a bunch of fixed virtual platform, modeling platforms, development boards that are ARM property. These are not counted in that numbers. And if you see the collaboration, so from when we started with the project, there were obviously, it was an ARM project, 0 comments from the community. Now it runs of about almost 1,000 of comments per year. So a hugely increase in the past 2-3 years since we opened up also the governance of the project. So how to get involved? Well, first of all, if you bump up an ARM platform and you want to see what is going on under the hood, so behind the kernel and behind the BIOS, there will be a tiny layer that is trusted firmware, and you can play with it. You can look at the code base, you can contribute, you can read the mailing list, participate to the project live, and it's all for free. Then if you want to be part of the project, if your company wants to contribute to the direction of the project, you might consider joining the TrustedFirmware project. So at that point, you will participate and own technical and strategic direction for the project itself. And finally, be a TrustedFirmware ambassador, as I am here on stage. So that completes the first slot. So what TrustedFirmware.org is. Now we've got the second part. It's a bit more technical. So what is happening from a standardization point of view in the open source firmware space on ARM, especially on the secure word firmware side? Here we go. So this is a high-level picture on how this secure word architecture looks like today in an ARM platform. So we've got the EL3, the highest privilege firmware, that usually is based more or less on the Trusted Firmware project. That's the blue box. But it has a lot of proprietary stuff coming from the silicon provider, coming from the ODM, coming from other entities. So when you have a secure service that you want to run on ARM, or a platform-specific service, the easiest choice to be is just to stack this service at EL3. So implement it within the runtime portion of the firmware at EL3, and that's it, like easy. So I grayed out the Trusted OS part here because it might not be relevant in all these segments. So we have deployments that looks like this precisely, and we have deployments from our partner that looks like that instead. So in this case, there is a Trusted OS, but again, there are a lot of, by this way, there are a lot of red boxes that marks silicon vendor-specific pieces that are added. They are added again at EL3. They are added at the secure EL1 layer within the Trusted OS in all sorts of places. So we want to try and solve this situation. Why? Which is the problem? So the problem is that with an increasingly complex EL3, standardization, audit, and certification becomes increasingly difficult. So the initial goal for the ARM Trusted Firmware project back in 2013 was to defragment the ARM v8 firmware space. And we have done a lot of steps in that direction, but if partners continues to add specific services at EL3, they just keep fragmenting the firmware ecosystem at the highest privilege level. So there are papers available in the internet in which security researchers continuously breaks proprietary implementation of the EL3 firmware because again, it's difficult to audit. It's difficult to certify it. So if we want to have a secure, highest privilege firmware, we want to have it clean. Other challenges, if you have a Trusted OS, there is no separation between EL3 and the secure EL1 space in which a Trusted OS runs. So effectively, you cannot enforce the principle of least privilege. And there is no way for protecting the normal world from attacks coming from trusted application and Trusted OSs. That's yet another attack vector that is very popular on research papers. So these are all the challenges. And this is more or less the dream that we have for the evolution of the firmware. So we would like to have, stick on this side, to have a standard and completely generic EL3 runtime firmware that will be delivered and provided by Trusted Firmware as an open source project as it is today. So we would like to encourage all our partners to move out all their platform-specific services and secure services that they need. So for doing DRMs, secure payments, secure storage, or crypto operations. So to move all these services out from EL3 into lowest exception levels in the secure world. So lower exception level like secure EL0. And what about platform-specific configurations like memory addresses and so on? So we've got already today in the code base a way for adding configuration files. It can be a build time or a runtime to the firmware. So you can have one single binary and configure the binary with your platform-specific parameters. You can do that today. So mixing these two topics, we would really like to arrive to a point in which there is a standard, audited, certified EL3 firmware for your platforms, and all the differentiator services are moved up to lowest exception levels. So how to arrive to this point from the previous picture? So we have to build an architecture, and we have been working on this architecture for 2-3 years now. So these are the building blocks. You may have heard of it in previous presentations. Also last year, an ARM employee, Sandrine, was here presenting some of these building blocks. So secure partition is an unprivileged software environment, a sandbox environment that runs in the secure world, in which you can run your secure services. The beauty of this secure partition, it's that it has an isolated execution context. So every partition is isolated from each other, and it has limited access to the system resources. So it doesn't see all your system resources. And who controls the visibility of the resources for a partition? The second building block, the secure partition manager. It's an entity that runs traditionally at EL3 for systems that are not yet 8.4 enabled. And this entity, we will see in a picture in a second, owns and enforces the principle of least privilege. So it basically tells which resources each partition is able to see. And it's also responsible for the runtime communication between partitions and between the normal world that is requesting a secure service. Okay, so I want to do a secure payment from my Linux OS, so I execute the service request, and this is the router that routes the request up to the specific partition that will execute the payment service in the secure world. And then, obviously, standard set of interfaces. So no proprietary stuff, no proprietary interfaces, ad hoc SMC calling SMC, but rather a standard set of interfaces that will really describe how these various entities communicate together. So the picture starts to look like this. So this is an early picture from 2017-ish that we completed the development upstream of this picture last year. So this picture is actually already available using the upstream project, TrustedFirmware, and Tiano Core, EDK2. So you basically have a generic firmware that implements the partition manager, the entity that controls that partition. There is a little shim that translates your request from the normal world to the secure world. And then here we go, the secure partition that can implement what is called a standalone service as defined by the UEFI PI spec. And in the Tiano Core EDK2, there is a package that is maintained by ARM and partners that implement standalone services. And we've got already platforms implementing this model that are available now. So this is one step in the right direction. It's not enough, though. It's not enough because this is allowing just one single partition to run in the secure world. So you can only have one service, one payment service, one DRM, storage access, secure storage access, only one in your platform. And that's the limitation. And then it also has still a run to completion model. So it means that the normal world is not in control of the cycles that are spending in the secure world. So there is the same problem that other architectures has on their secure systems. So the way forward is the evolution. And the evolution, so the picture is a bit complex, becoming a bit complicated. So the interface now changes. It becomes a more complex interface called Secure Partition Client Interface. How it changes, it allows multiple services requests to happen concurrently. So you can spawn basically multiple partitions, you can call into multiple partitions in the secure world concurrently. And it also allows yielding calls. So it means that the normal world is in control of the cycles that are spent in the secure world. So this prevents the cycle stealing problem that was affecting the previous picture. So the secure world is no more stealing cycles behind your hypervisor or behind your normal world kernel under the hood. So that's on the normal world side. On the secure world side, in order to allow multiple services and in order also to have trusted applications that can run together, we are working to enable this picture. So having a trusted OS and the TrustedFirmware.org project will deliver a solution based on opt. So hence the importance of having OPT migrated into the TrustedFirmware.org project. So we will provide a reference implementation not only of the EL3 firmware, but also of the Secure EL1 using OPT. The Secure Partition Manager will have work to do in the OPT core kernel as well, because it will have to decide if the requests that are coming from the normal world needs to land on trusted applications or on standalone services. And that's an implementation choice by our ODMs or our partners. So depending on which services fits mostly a trusted application, or other services might want to be separated. So if you have a specific secure storage access and you have a driver for it and you don't want to rewrite it as a trusted application, you can run it on top of OPT as a standalone service. On top of that, again, the blue box here means that ARM, through the TrustedFirmware.org project with the ARM ecosystem, is also going to provide reference trusted applications for PSA-specific services. So PSA services are a reality on the microcontrollers today. So services like crypto operations, secure storage, attestation. These will be ported as reference services on the application processors as well. And they will be ported as trusted applications running on top of OPT and delivered through TrustedFirmware.org again. So this is the picture that we are working on right now in the ARM ecosystem for the evolution of the secure world software. This is not the final picture, though, because this creates a nice and clean migration path. Lost it. Here we go. For what will come next. And what it will come next is written here, is the missing block in the middle here. So the next picture is, the final goal is to have a secure EL2 firmware. So someone would call it a secure hypervisor. We don't really like that wording because it's not going to be a real full-fledged hypervisor running in the secure world. It will mostly be a secure partition manager, as we saw it before, that will decide which request goes into which partitions on top. The beauty of this picture is that at this point, the isolation between various partitions, and in this case, there is one partition that embraces the whole trusted OS, and another partition that embraces all single possible standalone service that you could have. So those partitions will be isolated by the hardware, not by the software, as it was in the previous picture. So this is still a software solution. There is nothing in the hardware that prevents a compromised service to go around and play with the other services. This is a hardware-enforced solution. And this comes with the ARM 8.4 architecture, and specifically the Secure EL2 virtualization extension. So that's the direction of travel. Obviously, coupling this with the new SMMU architecture and geek architecture, this will give system-wide isolations also for all your peripherals in the system. And this will be our next-to-come development in the TF.org space. A topic for late 2019 and the rest of 2020. All the blue boxes, as I said, will be delivered as part of TrustedFirmware. And yeah, I think that's it. There are a few links. If you want to go and look at the project charter is publicly available if you want to consider joining the project. There is a white paper from ARM that talks about virtualization extensions coming with the 8.4 architecture. The previous presentation from Sandrine, OSFC last year regarding secure partitions, a deep dive on the status of the art back 1 year ago on secure partitions. Link to the platform security architecture framework from ARM, and the specification, SPCI, that will be called PSA firmware framework for the A-class processors will be coming out very soon from ARM. So that's it. Any questions?
Thank you very much. Let's have another round of applause. So we have time for about 10 questions, but since this is the end of day, we have virtually infinite amount of questions.
Question that one of your slides said you have a way to avoid the x86 SM stealing cycle from circuit. I didn't understand how you can prevent that.
So the specification, I've lost the slides, but the specification that will be coming out allows for specific calls that basically allows the normal word to tell the secure word how much cycles it's allowed to spend. And then there is a mechanism for the normal word to request basically an interrupt-based mechanism, to request the execution back to the normal word if it wants to.
Yeah, but that's still steering cycle. We have in x86, we have sliced SMM that we can cut a big program into pieces. So like Windows has a specification limit how long you can stay in the SMM.
Okay, but if your Linux kernel wants to use your cycles back, you cannot ask them back from the SMM.
Yeah, it's disappeared. It's disappeared.
That's not what it happens here.
Oh, okay. We probably need to wait until
we need to look at this spec deeply and see how it allows the normal world kernel to request your cycles back and bring the execution back to your Linux kernel when you need it.
Are there more questions?
Sorry,
Yes?
I'm repeating the question. Like, I think you know the question, but the thing is that this is the question that they're not quite related to development of ATF, but we are using ADF in U-boot for ARM64 as a blob, binary blob. Like we built out of tree ATF and we will reuse it in U-boot image format. Do you see any point of taking that code or forking that code into U-boot? And do you see any point with respect to licensing, or is it that seems like worth to fork that into bootloader like U-boot?
So I will repeat my answer, basically the same. So I'm not a lawyer, so I cannot really pronounce myself on the legal side of the licensing.
Okay.
What you can do is you can surely fork the project that will still keep its BSD permissive license, and you can mix and release it as part of U-boot. Now, how U-boot with its GPL v something license will cope with the inclusion of a BSD piece of code, that's up for you to sort out on the legal side. That's not up for me to decide.
Okay.
That's my political answer. Then we can discuss more with some licensing angles offline.
Okay.
Yeah.
Thanks.
Hey, Matthew. So one question was for the ARM v8, normally we have like in EL3 the secure copies of some of the registers like in JIC-V3 or SMMU. So in the last slide you sent, you mentioned about 8.4 that the firmware is going to be EL3 generic and you're going to push the secure things into the EL2, right? So the secure copies, do they become programmable in EL2 then, or how's that? I mean, or the secure copies go away in 8.4? Do you remember? I don't remember reading about that, but
I don't remember the particular detail. We can check it. So when I say the EL3 firmware becomes standard, we cannot enforce our partners to just get rid of everything that they have and just adopt everything that comes downstream from tf.org. What we can do is encourage, well, first of all, encourage platform ports to be upstreamed. Then we can encourage collaboration on topics like this in the mailing list, saying, look, we have this problem we usually, keep a secure state copy. How do we cope with that on Secure EL2? Do we want to move that on SEL2 and so on? That's probably the right direction to go. We can discuss it offline on the public mailing list. But that's the kind of direction. So we want to start now to tell partners, look, we would really like to clean up the EL3 space in order also for the coming of the SEL2 1 or 2 years out down the line. If you want to be prepared, we can start approaching the topic. Right. Otherwise, partners just will be caught unprepared.
Right.
That's what we would try to avoid.
Sure. Thank you.
I'm sorry, I'm very ignorant of all this, but my question is, you've got lots of microprocessors running inside the ARM chip. Why all this sealing of cycles and so on? Why don't you just dedicate one of them to secure stuff?
So let me see if I have understood the question. So in a typical ARM system, there might be multiple application processors. So you are suggesting let's reserve one of the application processor for doing secure stuff. Did I get it right?
Yeah, I guess that's what I'm saying.
Okay, so let's see how I can reply to that in 30 seconds. So every partner has its different kind of system. So there are systems with 8 mixed, very high-end Cortex-A cores. There are systems that are big little systems in the mobile space with completely different set of configurations. So every core counts a lot, and every application processor costs a lot of money to our partners. So what ARM is suggesting from a security standpoint, so is either go with a T-based solution like this one. So these are solutions to solve security on your application processor that you still have. But if you can afford having a separate coprocessor that does security, we are okay with that. And actually, the architecture allows you to reserve one of the partitions to communicate with your security coprocessor. It will probably not be a Cortex-A as we know it. It will probably be a specific security processor, and ARM has other IPs to suggest to our partners for doing this sort of operation. So coprocessor that does accelerate security operations, coprocessor that does discrete TPM implementations, coprocessor that does all the secure storage that you need. So we do have in our portfolio other products. So not the traditional application processor, because it will be a waste of money. So they are different. They are thought for different purposes. They are not optimized for accelerating crypto operations, for example. So we have separate hardware and IPs that are fit for that purpose. So we foresee a system in which you can have your set of Cortex-A that does your traditional job, and the communication with the security coprocessor goes through the trust zone, so it goes through the secure word, and you have a partition that communicates, and it's just a relay, basically. So it receives the request from the normal word, it goes in the secure, and then it gets relayed to your coprocessor.
So it sounds like the answer is yes.
Yes, but not with a Cortex-A, with a different set of ARM IPs.
But you're working on SoCs where there will be a security processor as one of the devices in there that will do all this stuff.
One of the optional deployment choice, yes.
Okay.
Yes, absolutely. So depending on the segment, again, it might be more popular or less popular, but it will be given the choice to our partners, absolutely.
Since no one is asking, so I ask my second question. Okay.
Yeah.
So in your slides, that ARM has a proprietary interface called SPCI. Right.
I prefer to call it standard rather than proprietary.
Standard. Okay. So what I have noticed, in the previous talk from the FSP, right? And they have the 2.1 version, and they start to use the native UEFI interface and their API interface.
Okay.
So it's pretty common, like even in a cell phone, that we carry a UEFI interface and also carry a device tree interface, something like that. So I just wondering, is it do you have any plan like making two type of interface for different world? For different firmware, right?
So I should go back to the picture, but basically, it doesn't matter what you run on the normal world. Thanks. So we can stop here. So it doesn't matter what you have in the normal world space here or here. So you can have, that's something I forgot to mention actually. Thanks for reminding me that. So you can have a normal world side as a bootloader. Trusted Firmware doesn't care. You may have core boot, you might have U-boot, you might have Tiano Core EDK2, or whatever proprietary BIOS implementation you want. And so how the BIOS or the bootloader exposes and communicates to the kernel, again, it doesn't matter from a Trusted Firmware perspective. What I'm talking about down there is how your Linux kernel or your proprietary kernel and how your bootloader or hypervisor calls into secure services in the secure world. So this at the moment is kind of not specified. So there are some SMC calls to arrive to EL3, but there is no way to call into the execution of these partitions up here. So there are a lot of proprietary SMC calls that lives down there or down there if it's coming from the kernel. So that's where we are standardizing. So we are proposing a standard set of interfaces that will live below your running kernel or below, below your running kernel or below your bootloader hypervisor, no matter what it is. It can be, again, U-boot, device tree based, CPI based, all this controversy. We don't care in the highest privilege firmware. So when we hand over the execution to the normal world bootloader, then the normal world does whatever it's meant to do.
So the memory sizing firmware is in TrustedFirmware or in the generic firmware?
The memory sizing, what do you mean by memory sizing?
The one that in the core boot, and they mentioned the block where to discover the memory, training.
So that's defined in the Trusted Firmware portion here. That's the runtime portion of Trusted Firmware, the EL3 firmware. That's what you are used to know today already.
Yeah.
So that is not going to change. So this will be even more generic, but it's exactly what BL31 is today on all ARM platforms. So the runtime portion of Trusted Firmware that lives as a secure monitor there.
SPCI may not be the only interface. There's other interface to the right? Because I haven't read the SPCI.
So SPCI will be how ARM recommends a standardize these interfaces, and we will provide the reference implementation across all the levels. If a vendor would like to have their own proprietary in place or in parallel, that will not be forbidden. So it's up to the implementation choice of our vendors.
Standard interface will still be there.
The PSCI? Oh, yeah, sure. This has nothing to do with the PSCI. So this is not meant to substitute the existing ARM standards. This is meant to replace specific proprietary ways of calling into the secure world. Absolutely. Yeah.
Okay, I may have to cut you off there because we're at the end of the day. So thank you again, Matteo. Please have another round of applause.